Alright, so in this video we're going to talk a little bit about addition. I want to start out with two good ways to think about addition, two models if you will. Keep in mind in the book in chapter 3 there are a few more models of division as well, so it's a good idea to read that. So read, it's either in 3.3 or 3.4, but it's a good idea to read those both to get the idea of the models for division. The two ways I like to think about it, it's either as repeated subtraction, kind of the opposite of multiplication. We'll talk about that a little bit later. But we can look at 21 divided by 4. We can ask, well, how many times can we subtract 4 from 21 without getting a negative number while still staying in the whole numbers? Well, let's check. We start at 21. We can subtract once, twice, 3 times, 4 times, 5 times. So we can subtract 4 from 21 5 times, and that leaves us at 1. We're unable to subtract again without getting negative, and we don't want to do that if we want to stay in the whole numbers. Maybe I'll make that clear here. We are talking about division in the whole numbers, so the natural numbers with 0. So repeated subtraction is a good way to think about division. The other way you could think about it is fair share. Well, let's say you have 21 objects and you want to divide them into groups of 4. How many groups can you make? Well, you just keep doing it. 1, 2, 3, 4, 5 groups, and there's 1 left over, so the quotient is 5. Our answer is 5 with a remainder of 1. And just going forward, I do want to point out there are different names for each part of a division. The number of objects we call the dividend. The size of each group we call the divisor. Our answer, the number of groups we can make, is the quotient, and the other part, the number that we are unable to group because there's not enough, we call the remainder. So that's a good way of thinking about division. Now we're going to talk about kind of what a good definition for division is. Remember, we want to kind of only use operations that we've already defined and talked about. So we're going to define it in terms of multiplication and addition. So the way we're going to define division, let's say we want division of two whole numbers here, a and b, we're going to define a divided by b to be the quotient with remainder r, where, let me tell you what these numbers are. They're the unique numbers where we can write the dividend a as q times the divisor b plus r. And there's only one way to do that, where your r is a proper remainder, where it's between 0 and b, but not including b. Notice the difference here. You can be 0, but you can't be b. So, an example, of course, 21. 21 we can write as 5 times 4, 5 groups of 4, plus a remainder of 1. There's only one way we can write 21, so that it's a multiple of 4 plus some remainder. And remember, your remainder has to be a whole number, so it has to be greater than or equal to 0. But it has to be less than 4, because if we had 4 of something, we could make another group. Remember, we're thinking of r as the number that are unable to be grouped, so it has to be less than 4, and 1 indeed is less than 4. So we can make 5 groups of 4 plus 1. So we can say, because we can write 21 like this, 5 times 4 plus 1, we can write 21 divided by 4 is 5, remainder 1. One thing I didn't mention, and those of you might have caught it, is that I said pick any two numbers in the counting numbers here. So this is from 1 to infinity. So it's not including 0. But we can update this to talk about dividing whole numbers. So I can change this to the whole numbers as long as I make it the case where we don't divide by 0. And we'll talk a little bit later about why we shouldn't do that. So let's say where, in fact, let me write this in green so that we know this just is because of whole numbers. We can't divide by 0, so our dividend's allowed to be any whole number you like, but our divisor can't be 0. We're not allowed to divide by 0. Okay, the other thing you may have noticed is this word unique. I mentioned it, and it kind of makes sense, but it's not 100% clear why there's only one way of writing this. And there's a result here in mathematics. We'll do this in black. It's called the quotient remainder theorem. And a theorem in mathematics, that's a buzzword, I guess, or jargon for a general result in mathematics that can be proven. That's pretty much it. It gets a little more complicated. Theorems are usually reserved for very important results. Results that aren't as important are maybe called propositions or lemmas or something like that. But for our purposes, we'll just use the word theorem to talk about any result that can be proved in general. So the quotient remainder theorem basically says the quotient and remainder, the Q and the R, in the above definition always exist. So they're always there. That is, you can divide any two numbers, A and B, as long as B isn't 0. So they always exist. And moreover, are always, and are always, I guess, and are always unique. So that's a nice thing about division. We always get one answer. Now for the proof, I always like to prove theorems. This one I'm not going to prove. It's a little, slightly beyond the scope of this course. It's not too bad, though. For those of you interested in figuring this out, let me give you some handholds. In fact, this is kind of more of a sketch of the proof, I guess. Let's say sketch. And you guys can fill in the details if you like. It's not too bad, but basically, the first part, let's show that it always exists. So existence. What we're saying for existence is as follows. Basically, start with your divisor. And keep track. Maybe I'll put a semicolon here. Keep track of how many times you can subtract B from A, and that gives you your quotient. Let's say before, while remaining and the whole numbers, of course. So the number of times will give you your quotient, and the last number you land on before, if you subtract again, you go negative. That, of course, is your remainder. So the number of times is your quotient, and the number remaining, number you're left on, is, of course, your remainder. So that's basically, I'm just basically saying keep track using repeated subtraction. Writing down the details is a little bit fiddly, and that's why I say that the actual proof is beyond the scope of this course. It's not super bad, but this basically gives you the exact idea of how to do it without getting into kind of all those fiddly details. But the uniqueness, how do we know we can only do this in one way? So the uniqueness, this is kind of a very common thing in math. To show something's unique, pretend that it's not. Pretend there's two of them, and then show that they must be equal. So pretend, say A is Q times B plus R, so we'll call this Q1 and R1, and A equals, maybe you can do it a different way, say QB and R2, so we'll call it Q2 and R2. So pretend that you can do it in two ways, then set equal, and once you set them equal, you can imagine, well, if they both equal A, they both equal each other, so we set them equal, then we get QB plus Q1B plus R1 equals Q2B plus R2. Then what you can do is get the QBs on one side and factor. And once you do that, reason, and I'll kind of let you guys think about this, but you should be able to reason that the remainders must be the same. Remember that they're both less than R, but not negative. So that'll be helpful. And then using that, you should be able to reason that Q1 equals Q2. So if you're interested in this, if you think this is a fun exercise for you guys to do, try it out. One's a little fiddly. I think this is good enough as a sketch. But for two, you guys should be able to do this if you're willing to put in just a little bit of time to think about what's going on. The whole key of it is, remember, these guys have to be non-negative, but they can't be R or bigger. All right, so let's say we have the following situation. We have y divided by 7, some number y. We don't know what number y that is, but it's some number. If we divide it by 7, we get some number of groups with a remainder of 5. We don't know the dividend. We know the size of the groups. We don't know the number of groups, but we know we're unable to group 5 of them. Okay, that's fine. Let's say from that information, can we work out what y plus 5 divided by 7 is? I think a good thing for you guys to do is to pause the video and see if you can figure this out. My suggestion is try an example. So pick a number y where if you divide it by 7, you get a remainder of 5. See if you can figure out one of those. My suggestion as well is try and draw it with some sort of diagram, like a fair share style diagram. And then figure out what 5 more than that is divided by 7. See if doing an example or two can kind of help you reason the pattern that's going on. It turns out that whatever y and q are isn't particularly important. It's the 7 and 5 that's the important bit. Draw a bit of a diagram and see if that helps you out. So pause the video and give it a go. See if you can figure it out. Okay, now that we're back, let's try something. Let's try y equals 19. I know that 19, if you divide it by 7, you get 2 with remainder 5. So this is a reasonable example. So I want to divide things by 7. I'm going to draw 19 dots. And I'm going to already kind of put them in groups of 7 as easily as possible, just by making the rows of length 7. So there is 14, 15, 16, 17, 18, 19. So you can see every time I get a row of 7, that gives me a group. So here's 19 dots, and I have 2 groups of 7 with 5 left over. So 19 divided by 7 is 2, remainder 5. And there's kind of nothing special about the 2, it's just the number of groups I have. Well, what happens if I add 5 to 19? Because that's what the question wants me to do. Well, let's check it out. Okay, so now let's do 19 plus 5 divided by 7. Remember, we're interested in kind of what's going on, not just the answer. So let's add 5 dots. So this is the same, of course, as 24. 19 plus 5 is 24. So 24 divided by 7. So remember, I'm adding 5 dots. So let me go ahead and do that. I'm going to add them in red. So here are my 5 dots that I'm adding. I'm going to complete the row if I can, and I can. 1, 2, 3, 4, 5. Now, what's interesting here is that, think about it. Did you care about how many rows were already made? You didn't at all. It had kind of no bearing on adding the 5 dots. Or, yeah, adding the 5 dots. We had these 5 dots initially, and we added the next 5. Well, 2 of those filled an additional group. So 1 more than what we had. And we have 3 left over. So we can look at it like this. So it is 3, oh, that's the wrong pen, 3, remainder 3. But I'm going to write it like this, because it's kind of more clear if I write it as 2 plus 1, remainder 3. So, and let me kind of mark down why I did that. These 2 were the 2 groups from 19 divided by 7. And this 1 here is the additional group from adding 5. So that's what's going on here. We get 1 more because we can make an additional group. And this remainder 3 are the ones still ungrouped. So we can't group 3 of them. Okay, so using that idea, pause the video now. See if you can think about it, well, for a number y and a number q here. Remember, these kind of didn't come into it, so see if you can write it down, looking at this as your example. 19 divided by 7 is 2, remainder 5. And 24 divided by 7, that's 5 more than 19, is 1 more group than 2, remainder 3. Okay, now that we're back, well, y plus 5 divided by 7. Well, let me draw the diagram again. 4, 5, 6, 7. And I'm going to do it like this because we don't know how many groups we have. But I am going to call that number q. So we have q groups if we do y divided by 7. And of course we have 5 remaining. So there is, in total, we have y dots. So everything in green here is y dots. Oh, hold on, maybe. I'm going to erase this a little bit because I'm going to add some dots here. So let me kind of jut that in a bit. There we go. So there are my y dots. I can make q groups of 7 out of them, whatever that is, with 5 left over. Let's add our 5 now. And look, the same idea is going to happen. It doesn't matter how many groups we have above. All that matters is, do we get another group? And in this case, we do. We have one more than q. So we have these q groups of 7 plus an additional 1. So we have q plus 1 groups now with 3 left over. So our answer is, of course, q plus 1, remainder 3. So hopefully that idea makes this question clear. It's always a good idea to ask yourself, can I make an additional group of, in this case 7, but an usual group of the size of the divisor, if I add something to the dividend? That's the idea. And just as an exercise for you guys, fy divided by, let's say, 5 is qr1. What is, let's do 2 of them. Let's do something small. Y plus 2 divided by 5. And the second one, let's do something big. What is y plus, let's say, 78 divided by 5. And the third one, well, let's get a little fancy. See if you can figure this one out. 2y plus 3 divided by 5. So pause the video now. I'm not going to go through the solutions. I'm going to leave them as an exercise, but I will tell you the answers. So pause the video now and see if you guys can work this out. Alright, now that we're back, I will tell you the answers. And again, draw some diagrams to help you here. So the first one is going to be qr3. Hopefully that one was easy. If you draw it out, it's almost immediate. You just don't get enough to make a new row. The second one, well, you have to be careful about how many new rows you make. And I will tell you that your answer's going to be q plus 15, remainder 4. The third one, you have to be a little more careful. Think about what's happening with your remainders when you multiply by 2. Again, draw it out, and it should, you should be able to see it. But I will tell you that your answer is going to be 2q plus 1 with no remainder. So you could write just 2q plus 1 like that, or some people like to write remainder 0 to make it clear that there's no remainder, but if you just had 2q plus 1, that's correct as well.